Welcome to the tokenized economy. Here is today's explainer on blockchain finality. In the world of digital assets, knowing exactly when a transaction is complete and can't be taken back, well, that isn't just some technical detail. It's literally the foundation of trust. That whole idea is called finality, and today we're going to break down why it is so important. All right, so how are we going to tackle this? First up, we'll get a clear definition of what finality actually is. Then we're going to explore the two very different ways blockchains achieve it, and we'll put them head to head. After that, we'll look at how this plays out in the real world. We're talking trillions of dollars here, before we wrap up with the big question. Why does any of this even matter?
Okay, let's start right at the beginning. What exactly do we mean by finality? Just think of it as the ultimate point of no return for any digital transaction.
So let's kick things off with a super fundamental question. When you're dealing with digital stuff, when is a transaction really final? And I'm not talking about sent or pending. I mean, when is it absolutely 100% no takebacks final? And that's where this whole concept of finality comes in. It's that exact moment when a transaction is considered settled for good. It's the digital point of no return. Once a transaction hits finality, you can't reverse it, you can't rewrite it. It is permanently etched into the blockchain. Okay, so why is this such a huge deal? Well, because finality is basically the bedrock of any financial system you can actually trust. It's the thing that guarantees settlement. It provides the legal certainty so everyone knows who owns what, no questions asked. And, at the end of the day, it's what enables effective risk control. Without it, the whole system is just built on sand. But here's where it gets interesting. It turns out there isn't just one way to get this done. Blockchains actually take two totally different roads to get to that point of absolute certainty. So on one side, you've got what's called probabilistic finality. And on the other, you have deterministic finality. You can almost think of it as a difference in philosophy, right? Is certainty something that gets stronger and stronger over time? Or is it something that should be instant and absolute right from the get-go? All right, let's really put these two approaches head to head. What are the key differences in how they're built? And maybe more importantly, what is each one for? Okay, this is really where you see those two philosophies in action. So first, let's talk about probabilistic finality. This is what networks like Bitcoin and Ethereum use. The idea here is that certainty grows as more and more blocks are added after your transaction. The chance of it ever being reversed becomes ridiculously small over time, but it's never technically zero. And that's the trade-off, right? You get this incredibly open, permissionless network, but you give up that instant absolute guarantee. Now, on the flip side, you've got deterministic finality. This is used in systems built for business, like Canton, and it is immediate. The second the network agrees on the transaction, boom, it's done. It is legally and irrevocably final. The trade-off? Well, these networks are usually permissioned. They're built for control and for meeting regulations. Okay, so let's move this out of the theoretical and into the real world. Because, believe me, this is not just some academic debate. We are talking about trillions, with a T, of dollars on the line. Yep, $9 trillion. That is not a typo. Just let that number sink in for a second, because that's the kind of scale we're talking about with these systems right now. So where does a number like $9 trillion even come from? Well, that's the monthly volume in the repo market processed by just one platform, Broadridge's DLR, which is built using deterministic finality. It just goes to show you the massive scale these systems are already handling in high-stakes finance, where you absolutely need that certainty. But at the same time, the public chains aren't just standing still. You've got networks like Ethereum constantly pushing out upgrades to get faster block finality, trying to shrink that window of uncertainty to make their model even better for all of us. And all of this brings us to our final and honestly most important point: why this choice actually matters. When it comes right down to it, it's all about using the right tool for the job. It really boils down to this one simple but super powerful idea. And the quote says it all: finality choices map directly to real-world needs. Probabilistic finality supports open, censorship-resistant networks. Deterministic finality supports regulated settlement and legal finality. See? It's not about one being better than the other. It's all about which model, with its specific set of trade-offs, is the right fit for what you're trying to do. And that leaves us with a really fascinating question to chew on. As both of these models keep evolving, keep getting better, and keep handling just incredible amounts of value, which one do you think will build the future of finance? Or maybe it'll be some combination of the two. So there you have it. That's finality in a nutshell. Look, whether you're on team gradual certainty or team instant guarantees, getting a grip on this concept is absolutely key to understanding the future of digital assets. For more short explainers on blockchain, tokenization, and financial markets, make sure you subscribe. And we really do want to hear from you. Share your questions or topics you want us to cover in the comments.